Hey everybody, my friends. We're starting 2.10 part one, and this is called tangent line approximation. And I gotta say, to me, this is one of the most fascinating areas of calculus, or one of the most fascinating topics that we're going to be doing in calculus. So let's just take a quick look at it. So let's say I have a curve. I have a curve. Some function, and it's y equals f of x. And I want to know the value of f at some random point. Let's say some random point x. So this is x. This point would be the point x comma f of x. I want to know that point. Well, let's say I have a point A, which is nearby. Always better drawing these things. And I'm going to call this point is A. So this point over here is A comma f of A. And I draw a tangent to the curve. This is supposed to be a perfectly straight line. See how great my lines are. And A is a straight line. In fact, I can give you the equation of not A, but this line here. I'll call it L. I'm just going to call line L. And L is a straight line. And the equation of L I can get very nicely because, we know that from the point slope formula, y minus y1, which in this case is f of A, equals m times x minus x1. But m, the slope, is just f prime of A. So we have y. I'm going to bring the f of A to the other side. Y equals f of A plus f prime of A times x minus A. And this formula here, this is the equation of the tangent line. That's why we say tangent line approximation. And because it's a straight line, it's very easy to figure out that, a straight line has an equation, and I just plug in an x value and I get a y value. But to get the y value for the red curve, you see that's a little different because it may not be a curve that's easy to just plug a number into. So my point is that since it's easy for me, relatively easy, to figure out the y value at that point because it's on a straight line, I could use that as a nice approximation for the y value of x f of x. And this works when the x is fairly close to the a's, because as you go further out, the red curve and the black line sort of diverge more and more. So as long as you're fairly close by, it's going to work. So let me give you a example of this. And this is where, again, I just find fascinating. Suppose we want to find the square root of, excuse me, we want to find the square root of 4 point, give me 1 second here. We want to find the square root of 4.08. So what I'm going to do is I'm going to look at the curve y equals the square root of x, and I'm going to find a point A, which is easy to figure the value of. And I'm going to find a point A where it's a perfect square. I want to find a perfect square that's pretty close to 4.08. So a very nice perfect square would be, very nice perfect square nearby would just be 4. 4 is a perfect square. So what I want to figure out here, I know. So I'm going to use my linear equation here. So I'm going to say y is equal to f of 4 plus f prime at 4 times 4.08 minus 4. Because we're dealing with a case where x is equal to 4.08. Because that's 4. That's 4.08, so to speak. I don't know if this is the curve of, this is not really what the curve of, this is not what the square root curve looks like. Give an example. Anyway, but I need to know, well, f of 4 is the square root of 4, which is 2. That part's easy. But what is f prime of 4? Well, that's where calculus comes in. So using some calculus, we know that if y equals the square root of x, if y equals x to the 1/2 power, y prime equals 1/2 x to the 1/2 minus 1 power, which is, in other words, y prime equals 1/2 x to the negative 1/2 power, which is the same thing as 1/2 radical x. So this is going to be f prime of 4 is going to be 1/2 times radical 4 times 4.08 minus 4, which is 0.08. Of course, rad 4, this becomes now y equals 2 plus 1/4 times 0.08, which is equal to, of course, 2.02. That means that so that means that the square root of 4.08, that means that the square root of 4. That means that the square root of 4.08 is approximately 2.02. Now, let's look at this with a calculator. So the approximate value, our approximate value is 2.02. What is, using a calculator, that wavy equal sign means approximate. Using a calculator, I get square root of 4.08 equals 2.0199. So look at that. The exact answer using a calculator is 2.0199. The approximate answer using this method was 2.0200. If I subtract, I get 0.0001. So in other words, without using a calculator, I was able to figure out the square root of 4.08, and it was accurate. It was accurate within 1/10,000th, which is unbelievable. It was accurate within 0.0001, and that is unbelievable. That is unbelievable. Why did I say unbelievable? Because here we are, we're using a low-tech method. In other words, I didn't need a calculator. All the calculations I did were things I could easily do by hand. I just had to subtract, like here I had to subtract some numbers. Here I had to divide by 4. I took a square root, but I specifically picked a number that was easy to get a square root, a perfect square number. So I took a perfect square here. All my the hardest thing I had to do was to take 8 divided by 4. Wow, that was tough. This is really quite a powerful thing, and this is the kind of thing I find fascinating. I've always found this sort of thing fascinating, meaning using low-tech methods, using creativity, a little math, a little insight, a little creativity to get very high-tech results with very low-tech methods. And this is a tangent line approximation. Very fascinating topic. I want to switch cameras and just show you some. That's me. Share my screen. Okay, so this is from my textbook. This is a little more like the official definition, or just this is really kind of a summary of everything we just did. So to approximate the value of f of x using TLA, we find some a where a and x are close, and you know the exact values of both f of a and f prime of a. So, which is what I did. I strategically, let a be the number 4, which is easy to find a square root. And then f of x is approximately equal to f of a plus f prime of a times x minus a. And as we said in our, formula. And another way to look at this is that f prime of a is delta y over delta x, so delta y is f prime of a delta x. That's just another way you can look at it if you like looking at it that way. And the only thing I want to know now is how close is close. We said close. What does it mean close? So how do you get this? This thing here is so annoying. Anyway, how close is close? So here's my AF of A. Notice that the curve. In this case, the straight line. They put the straight line on top and the curve on the bottom. But as we get further and further away, the straight line, the curve move far away from each other. This is how the textbook gives it, and we're in good shape here. So the tangent line approximation. This is our big formula right here. That that the function value is going to be approximately equal to the line value, which is f of a plus f prime of a times x minus a, and that is beautiful. Okay, everybody, I'm going to continue in section 4.10, and I'm going to continue in section 2.10 in part 2 of our video. So this was part 1. It was a lot of fun, and I'll see you guys next time. Bye, everybody.